Short video, we consider a simulation that has a thin lens and also an object that is movable. So I can take this object, my object in this case is a pencil, and I can move it back and forth. And what we're going to do in the simulation here is we are going to change some of the properties of the lens. So we can adjust the curvature of the lens, the radius of curvature of the lens, and we can change the index of refraction of the lens and see how that might affect the focal length and the focal point of the lens. So in this particular simulation, my object is located on the left. My thin lens is in the center, as we can see, and then we have an X on either side of the lens that represents the focal point of the lens, and the focal length is the distance from the focal point, the X, to the center of the thin lens. So let's start by considering what happens when we change the radius of curvature of the lens. So I'm going to increase the radius of curvature of the lens, and let's take note of what happens to the focal point. So as I increase the radius of curvature of the lens, the focal point moves farther from the lens, and therefore the focal length, which is the distance from that point to the lens, increases. So an increase in the radius of curvature causes an increase in the focal length of the lens. Let's go ahead and go back. Move that radius of curvature back, and now let's adjust the index of refraction. So the index of refraction is basically based on what this lens is made of, and a larger index of refraction implies that the light will bend more when it enters the medium. So I'm actually going to go ahead and move the curvature out here. So let's go ahead and see what happens again to this focal point on either side of the lens as I increase the index of refraction while keeping the radius of curvature constant. So I'm going to increase, and as I'm increasing the index of refraction, the focal point is moving closer to the lens. So as the index of refraction increases, the focal length and the focal point, well, the focal length decreases and the focal point moves closer to the lens. So an increase in the radius of curvature causes an increase in the focal length, and while an increase in the index of refraction causes a decrease in the focal length.